Well, good afternoon, everyone. I'm Frank Catapano. Couldn't be more pleased to be here to announce our partnership with Plant Life Company in the cannabis industry. And SD Labs is a company, we're about delivering solutions to the marketplace that can improve your efficiency, help mitigate risk, improve the hygiene profile of your facility, and really help protect your crop's profitability and reputation, right? Which is why we're all here today. So we're going to focus on what are referred to as common non-porous surfaces, which are the vast majority of surfaces you'll find in your types of facilities. So, what's the problem out there? And, people, including myself up until 10 years ago, took cleaning for granted. And when Joe and I looked at this marketplace, we found that it was really broken to the point where when you really start measuring and try and understand what's going on, most of what's done out there doesn't actually do a very good job in terms of cleaning and disinfecting. And there's just a fundamental lack of perception and understanding of what clean really means. And I think it's important to your industry because, if you guys lost a crop, it could be financially devastating. And if you look at innovation in the cleaning and disinfecting industry over the last 20 or 30 years, there really hasn't been a lot of innovation. And with that, I'm going to turn it over to someone who's much smarter than me on these topics. So, Joe, the control is yours, I believe.
One of the questions that we've asked ourselves over time dealing with this area is, what does clean mean? And so we thought today that we'd go through cleaning and disinfecting and some new technologies to explain to you guys where we're coming from. So the process of cleaning a surface typically involves wiping or rubbing to create friction that removes the debris from its interaction with the surface. And then we brush and sweep or vacuum to remove solid materials as well. But of course, cleaning involves the use of various solvents to help the process, to help release the dirt from the surface. Solvents are important to help with the cleaning process, and water is the universal solvent. It helps loosen foreign matter from its interaction with a surface, and it aids in the suspension of that soil and dirt and prevents its redeposition onto the surface. There's not just water-based solvents, there are organic solvents like butoxyethanol and limonene, but a key component of most cleaning chemicals are surfactants. Surfactants help the solution that you're using to wet the surface, to disperse on the surface, and also they can help in suspension and emulsification and penetration of the dirt that's there. So that's really how cleaners work, how surfactants help them to do their job. How do you choose the proper cleaning product for your job or your facility? You have to have a few basic considerations: the nature of the surfaces that you want to be cleaned, the types of soil and foreign matter that accumulate on surfaces in your facility, any environmental concerns, potential chemical interactions with other chemicals that you have in storage or use on a daily basis. You have to think about whether or not a certain type of cleaning agent could damage the surface, or more importantly for you guys, have some kind of damage to your plants. And of course, whether there's safety and toxicity impacts for workers who are applying those products. So when you choose a cleaning product, you got to plan ahead. You should choose a chemical cleaner that doesn't interact with the subsequent products that you'll use in a negative way. The bottom line is, no matter what the cleaning agent, improper or incomplete cleaning efforts can have a negative effect on how those cleaning agents perform, as well as how subsequent uses of disinfectants and surface protectants can work. And this slide just reminds me to remind you that the process of cleaning only removes debris from a surface. It doesn't really kill anything. Disinfecting kills microorganisms, and disinfecting should be a complementary step to cleaning. So let's talk about disinfectants. What are they? They're chemicals or other means used to prevent the growth of, inactivate, or kill microorganisms. Disinfectants are not sanitizers, and they're not sterilants. They are disinfectants. The US EPA registers them. There are limited disinfectants that really work only on a select few microorganisms. There are more general, broad spectrum disinfectants that work on many more microorganisms, and hospital-grade disinfectants work also on those pathogens that can cause serious diseases. Standard application of disinfectants are what we all know. It's how you apply the disinfectant to a surface where microorganisms are already present, and you allow time for the chemicals in the active ingredients in the disinfectant to work. The disinfectants typically poison the target organism and leave some type of residue behind, either the dead organisms or some breakdown of the chemical groups that are used in the disinfectant. As I mentioned, there are many chemical classes, from acids to azoles, biguanidines to halogens, peroxides to phenols. So disinfectants are cidal. They actually kill microorganisms. So they're bactericidal, fungicidal, virucidal, etc. Many disinfectants are also called microbicides, have pleiotropic effects on the organisms. They have broad spectrum activity on multiple cellular targets, and that's how they kill the cell. They can cause damage to the cell wall, the cell membrane, proteins, DNA, etc. So these pleiotropic effects make it more difficult to select resistance against disinfectants. So disinfectants work. I mean, we all know that. They work well, but there are some challenges. May damage surfaces or crops depending on which disinfectant you use. PPE may be required. Not all are safe for the environment. There's environmental concerns with regards to residual toxins left on the surface. There's possible chemical interactions and interactions with the use of subsequent products. But I really want to focus on these next two challenges: dwell times not being respected. So disinfectants and their activity depend on the amount of time they have wet contact with a surface and with those microorganisms. It's usually about 5 to 10 minutes to make sure they do their job, that they kill the microorganisms there. So that's one of the biggest challenges with doing disinfection. The dwell times are really not followed. And the next bullet shows that it's difficult to attain 100% surface coverage. There are corners of the room, under tables and things that are breeding grounds for microbial growth. And oftentimes when you spray disinfectants, you often miss these areas. So disinfectants aren't without a challenge. This 6-step protocol really just outlines what an effective disinfecting process should be. As we talked about before, you got to clean the surface and rinse it, allow that surface to dry, apply your disinfectant, try to get 100% coverage, respect those dwell times so that it can do its job, and then wipe dry or allow it to air dry. So that's sort of disinfecting chemicals and disinfecting processes. What I'd like to finish up my part of today's presentation is discussing antimicrobial surfaces and antimicrobial coatings. These are relatively new technologies compared to disinfecting, which has been around for 80 to 100 years. So these new technologies can help to maintain cleaner surfaces. So the idea is to use surface coatings to help keep bioload on your surface lower. So these types of surfaces provide ongoing protection between your cleaning and disinfecting steps, but they're not a substitute. It's an enhancement to current practices. But I'd like to talk with you today about organosilane-coated surfaces. So what are organosilanes? They're silicon-based coupling agents, and they've long been known to have surface binding and self-polymerizing properties. The general chemical structure is shown here on the right: a silicon atom flanked by some hydrolyzable chemical groups, a chemical linker region, and then a nonpolar organofunctional group here. But basic silanes can be modified to possess antimicrobial properties, and a molecule such as that is shown here on the right-hand side. It has the silicon atom at the bottom, the reactive groups. A linker in this case has a nitrogen atom followed by that long carbon chain, which is the business end of the molecule conferring antimicrobial activity. Once they bind to the surface, they're non-leaching, and they kind of have a physical antimicrobial mechanism of action in that they actually disrupt the cell wall and cell membrane and protein coat of organisms. So the next slide just introduces our product called Surface Defense 90, which is based on an organosilane. A cartoon of the product here is shown with the same type of silane molecule in orange, the nitrogen linker and the long carbon chain in green. Our active ingredient is called DTN 100. It's specially made for us, and it's registered with the US EPA. And once it's deposited on a surface, when the organisms come in contact with it, their membrane and cell walls are disrupted, as shown here in these electron micrographs. It's interesting that this same sort of mechanism is used in nature by the dragonfly. They have similar type of long carbon chains deposited on their wings, and we like to say our active ingredient here is a chemical mimetic of the pillars that are on dragonfly wings. So once again, this is kind of new to the cleaning and disinfecting field, although the chemicals have been known for a long time. It is kind of new technology, but new technologies and new approaches are required to address new challenges. The organisms we encounter daily can adapt and change, but often the methods we've used to control them have not. And our partnership with Plant Life Company offers a new approach. We'll try to understand your needs and objectives, educate you when necessary on proper procedures, introduce chemical innovations that mitigate risk, deliver new technologies and new tools, all with the intent to help make a difference in your facility. So I'm going to stop there, turn it back over to Frank so he can tell you about the room reset program that we've developed with Plant Life Co.
Thank you, Joe. Great job. So this section of the presentation will deal more with the chemicals that we're offering through Plant Life Company related to the Better Room Reset. So obviously it's a three-step process, sometimes complemented by a fourth, where we're cleaning, disinfecting, and then applying a surface coating with residual antimicrobial activity to reduce that organic load that Joe had mentioned earlier. Our SD Clean product is a ready-to-use cleaner and degreaser. It's phenomenal in removing soot, mold, grease, inorganics, and organic products. Just a very good all-around general surface cleaner. Electrostatic sprayer, Hudson sprayer, trigger sprayer, mop, hand. What's important is applying enough product to make sure that it removes the surface contamination, as Joe spoke about earlier. Vital Oxide is a pretty magnificent product. When we were looking for a disinfectant partner early on in the evolution of the company, we were looking for something unique. This is a EPA registered, hospital grade, broad spectrum disinfectant. Kills a tremendous number of organisms out there. It's also NSF approved for no rinse application on food contact surfaces. So think about surfaces in your facilities where you might be cleaning or producing or packaging your products. Having a product like this isn't going to put any type of contaminants into those products that might come in contact with it. Comes ready to use, does an exceptional job on mold. Very similar, you could use it in floor scrubbers, carpet scrubbers, same form factors as all of our products. And here, it can be applied really using any mechanism that you like, but we'd like to ask you to apply it so that you, have enough product on the surface to meet the dwell time, which is how long it needs to stay wet on the surface to kill all the organisms on the label, as well as attaining 100% coverage. Our SD90, sort of the star of the show, is a long-lasting surface coating that continuously controls bacteria, mold, fungi, and algae that can cause surface damage, stains, or odors. We're trying to use this to reduce the amount of contaminants that are stuck to a surface. So by eliminating those types of bacteria and molds and algae, it allows cleaning to be done more quickly, potentially with less product. It allows disinfecting to be done more quickly and gives you the opportunity to use less product as well. And again, this product is always on, so it works 24/7. Because of how it binds to and becomes part of the surface, it's very difficult to abrade this away. So you can wash a surface with non-abrasive cleaners, disinfectants, ours or generally anyone else's, and this coating's not going anywheres. So we'd love for you to use either a fine mist sprayer or an electrostatic sprayer when using this type of product. When you're done applying it, you want to make sure you rinse the sprayer equipment with hot water. This is a product that's designed to stick to surfaces. So if you don't get rid of it and remove it from your equipment, over time, you can gum up the works of that equipment. Very different way of looking at things. And again, it falls into that, let's be proactive and try to reduce the amount of surface load in real time. I mentioned ATP. We'll follow up another time, hopefully. This is a way to measure how clean or dirty a surface is based on the presence of an enzyme called the adenosine triphosphate. If you have a low level, the assumption is that the surface is relatively clean. If you have a high level, it's relatively dirty. And then we have a family of electrostatic sprayers that provide benefits in terms of speed, reduction in product costs, and the ability to treat large areas very quickly. Many ways to apply the products. Okay, trigger sprayers. This Flairosol puts out a very, very fine mist. This is the AC powered electrostatic sprayer. Battery powered electrostatic sprayers I mentioned. There's a General Hudson sprayer, a battery operated non-electrostatic sprayer. And this system is what we use when we're doing a commercial application, typically of our longer term products, so that we can get in and out of a site very, very quickly. And the reason that we're cheerleaders for electrostatic sprayers is that when you have a conventional sprayer, you get somewhat large droplets. And with an electrostatic sprayer, you get a finer mist, and we can benefit from what's called a wraparound effect, where because we're putting an electrical charge on the product that you're spraying, it will wrap around as it tries to get to a grounded electrical potential. So this saves time, saves money, and provides much better coverage than the typical sprayers that we're all used to. And this is an example of a trigger sprayer that one would find on a Windex bottle, a Fantastic bottle, what have you. And here, when you spray it and analyze the droplet pattern, you get 65% surface coverage, and you're using roughly 1.2 grams of product. When you go to a Hudson sprayer, you get a little bit better coverage, but you're using about 50% more product. And if you use an electrostatic sprayer, you get 100% coverage using a third of the product that you would typically use. So you're doing more with less, you're saving on chemicals, whether they're ours or someone else's. So at this point, I'd like to give a little shout out to Kendall Fisher and Brad Whitney for their support on trials that were done before Plant Life agreed to partner with us. They wanted to test this with a number of customers. And Kendall, if you could maybe spend a minute or so sharing your experiences with the product, we'd greatly appreciate that.
Yeah, no problem. Thank you guys for having me here. So for the cleaner, we really like to use that on our benches and our dry room floors. We've noticed that we're getting a lot of the resin and the organic buildup off of those areas. So we've also seen in our dry rooms, our floors aren't getting as sticky as they were before. And then we've been using the sanitizer on all of our flower rooms, our benches, our dry rooms, and that's been really helpful. So paired with that electrostatic sprayer, we have spray foam in some of our ceilings, and it's really able to get in there nice. Then the SD90 has given us a lot of peace of mind, knowing that, when we're hitting like the pipes behind the benches and the hard to reach areas, we knowing that that's staying clean the whole time. So we had some areas where we found mold before, and we've treated the pipes, stuff like that, under the benches with the SD90, and we haven't seen it come back, which has been really nice. I've also deployed it with our in-house sanitation, and we've had a couple of cases of COVID that were brought in from the outside. And fortunately, it didn't spread through the facility like it did in previous years. So it's been great for our plants and our grow rooms, but then also great to keep our teams healthy too.
Thank you, sir. Much appreciated. In the spirit of making life easy, what we're offering as an introductory program is enough product to treat about 13,000 square feet of area. And we put together a handy dandy little kit that includes our cleaner, the vital oxide product, which hopefully you'll apply electrostatically, our SD90 product, a handful of those Flairosol sprayers, a battery operated electrostatic sprayer with a spare battery, half mask respirator with cartridges, and safety glasses. And wanted to make it easy. You could purchase these directly off of Plant Life Co.'s site. And then we offer some standalone products prepackaged to make replenishment easier. We have spare parts for everything that we offer, obviously. And David and Scott have become de facto experts on this topic, but if they don't have a question, our team is always available to everyone on this call and any customers actually for support. So with that, I don't know if there's any additional questions. We had a couple in the chat room. Billy Green wants to know what the dwell time for vital oxide is. It depends on the organism. For example, SARS-CoV-2 virus for vital oxide has a 1-minute dwell time. Some of the organisms that may have a sporicidal shell may have a dwell time of up to 10 or 15 minutes. So we can provide that information. If you have specific organisms that are of concern, just let us know. And actually, Billy, on the vital oxide product label, there's an amazing amount of information that specifically lists the kill times for different major bacteria and viruses. And we can also send out the detailed EPA label. So with that, you can email David and Scott as a follow-up. I appreciate your time. I think I speak for David, Scott, and Joe. Thank you for your interest, and we're here to serve. So anything we can do, if you have questions, ideas, thoughts, we'd love your feedback and love to hear from them. So I thank you all again for your time. Stay safe.